Hello everyone, I hope you all are doing well. In this video, we are going to try and understand the term work, which is a scalar quantity, its units, and the derivation for the general expression for work. Now to begin with, first of all, in physics, work is said to be done when a force applied on a body produces a displacement. That means the body has to move. So if supposing there is a body at rest, okay, we apply force to it and the body undergoes a displacement. The body moves from one place to another, right? If it undergoes a displacement, then we say work has been done. So I'm repeating again, work is said to be done when a force applied on a body produces a displacement in the direction of the force. Now that last part of the definition I'll be explaining a bit later. So how we write it in formula form or as an expression is work is force multiplied by displacement, and it is a scalar quantity. So basically, for work to be done, two conditions have to be met. Firstly, a force has to be applied on a body, and second condition is the applied force has to produce a displacement in the direction of the force. Now there are so many examples like in our day-to-day life, supposing you as students are studying, sitting at one place and studying. In physics, you have not done any work in terms of, the definition. If you are pushing against a wall, I can be pushing against this wall with all my strength. After a few hours, I collapse, I get tired, but work done is still zero. Why? Because the force has not produced any displacement. So F multiplied by 0 will give us 0 work. Now we come to the unit. Now the unit of work, okay, the SI unit, will be the unit of force, which is Newton, multiplied by the unit of displacement, which is meter. So Newton meter, which has been replaced to honor the name of a scientist. So Newton meter is a joule. So the SI unit for work will be joule. Okay. Now let's define this unit. So SI unit is joule. Then there is a CGS unit also, the smaller unit, CGS unit of work, which is erg. Okay. So definition and the SI unit and the CGS unit. Then in ICSE, they also ask us to define the unit. Okay. Meaning, supposing you are asked definition of the SI unit of work or definition of 1 joule work. Okay. When you are asked to define this, how we go about defining is the formula helps us. So if you ever get stuck, okay, if you have not memorized it or if you get stuck, the formula will help us. So work is force into displacement. To get our answer of 1 joule, the force applied should be 1 Newton, and the displacement has to be 1 meter. So if a force of 1 Newton produces a displacement of 1 meter in the direction of the force, then we say 1 joule of work has been done. If you're asked to define the CGS unit, okay, again work is force into displacement. So 1 erg work will be done when a force of, now the CGS unit of force is dian, if you remember, class 9, and the CGS unit of displacement or distance is centimeter. So 1 erg of work is said to be done when a force of 1 dyne displaces a body by 1 centimeter. Normally in ICSE, they ask us to define the SI unit of work. Now, since there are two units, okay, we see the SI unit and there is the CGS unit, there has to be a relation between the two. Now, let's understand how are they related. Again, this is a derivation which comes quite often in ICSE. Relation between the CGS and SI units of work. Now to establish a relationship, again we go back to the formula. Work is force into displacement. So I'm going to start with the SI unit. Work of 1 joule means when the force acting on the body is 1 Newton and the displacement produced is 1 meter. Right? So 1 Newton meter is basically 1 joule of work. Now, since we have to establish a relationship between the SI and the CGS unit, I'll change this on the right hand side into CGS. Okay, so that means 1 Newton, if you remember from the previous chapter or in class 9, is 10 to the power 5 dynes. Okay. And 1 meter is 100 centimeters. Now when we multiply the two, we get 1 joule is 10 to the power 7 dyne centimeter. Right? So 10 to the power 5 and 10 to the power 2, it's 10 to the power 7 dyne centimeter. And this dyne centimeter is nothing but an erg. So from here we get 1 joule is equal to 10 to the power 7 ergs. So this is how they are related. So in ICSE, if you're asked just to write the relation between the SI and the CGS unit, you just have to mention this. If you're asked to derive the relation, you have to go through the entire process. Okay. Now, just in case they try to trick you by putting things the other way around. Supposing you are asked 1 erg is equal to how many joules? Any relation between two units, if you're asked the other way around, just reciprocate. 10 to the power 7 is the relation this way. You write 1 by 10 to the power 7. This is how it is related. So basically, we can say 10 to the power minus 7 joules. 1 erg is 10 to the power minus 7 joules. So this was regarding the units of work and the two units, how they are related with one another. Okay, now let's try and derive the general expression for work. Because if you remember, when I was mentioning the definition of work, force into displacement in the direction of the force. Now, normally, force and displacement do not always happen in the same direction. For example, while playing carom, okay, when you are striking, you use your striker to hit a coin, the striker moves in a different direction, and due to the force applied on the coin moves in a different direction. So normally, force and displacement are not always in the same direction. There is a certain angle between them. So supposing this is a situation, right? Or say a potter is carrying a weight on his head and is climbing up a slope. Or you're playing carom. So here's the object. Force was applied to it in this direction. The object has moved up here. So this is the displacement S. I'm taking this as the actual displacement. Now from this end position, I drop a perpendicular down 90 degrees. Okay. And I name this triangle as A, B, C. This angle between the actual application, the direction of the force, and this displacement AC, this angle is taken as theta, a Greek alphabet theta. Now let's see, work according to the definition is force multiplied by displacement in the direction of the force. So here in this case, it is F multiplied by the displacement in the direction of the force is not AC, but see the force is acting along this line. Okay, so the displacement in the direction of the force is AB. So F into AB. Now since the actual displacement of the body you can see is S. Okay, let us try to link these together. The angle between the force and displacement, the displacement in the direction of the force, and this actual displacement. So for that, we are going to use a trigonometrical ratio, cos theta. Okay. Now, cos theta is based by hypotenuse. Now, in our particular case here, cos theta will be the base of the triangle, which is AB, by the hypotenuse of the triangle, which is AC, or S, since I've taken S there. Now, if I cross multiply, I get AB is equal to S cos theta. And I put it here in this formula here. So W becomes F multiplied by S cos theta. So Fs cos theta. So now this is called the general expression for work, meaning the mother-father formula. Byproduct of this is that other formula which I've been using so far, W is equal to F into S. That will happen provided cos theta is 1. Okay, so this is called the general expression for work done. And in the next video, we are going to understand how this angle comes into play for maximum work done, for minimum work done or no work done, and for negative work done. So thank you. Thank you for watching the video.